Active Directory Physical Topology. In this nugget, we're taking a look at Active Directory's physical topology. And the reason why that's important is because we need to make sure that we don't use intra-site replication everywhere. You see, that works great within a single area of high-speed connectivity, but it's horrible for WAN links. You don't want to use it across different sites. And that's why we have to configure different sites in Active Directory and tell Active Directory information about it. Once that takes place, through the appropriate connection objects, for example, then we'll have inter-site replication that takes place on a much more efficient way for WAN links. Then we take a look also at bridgehead servers, which are configured automatically, but you can manually configure them as well. And these are your entry and exit points for Active Directory replication. Then we'll take a look here at site link bridging as well, which is a great way to make sure that you have transitive replication in non-fully routed networks. And then finally, we'll consider some special considerations that you need to really pay attention to for our exam objectives. Alright, since it happens to be my birthday today, I think it's only appropriate that all of us just join in together and sing happy birthday to James. Even if you're in the middle of a crowded cubicle farm or something like that and there's people all around you, don't worry about those strange looks you're going to get, that kind of stuff. Just go ahead and start singing. Ready? Happy birthday to James. I get the feeling you're not singing along. Don't worry about those people around you. Let's try it again. Happy birthday to James. Okay, on key this time, right? Wait a minute, I kind of get the feeling you're not really singing along. Kind of hurts my feelings a little bit that you're not willing to do that for me. But that's okay. I'm going to still teach you a really good lesson today, a good nugget, because that's just the kind of guy I am. I'm so forgiving that way. Alright, let's go ahead and take a look here, first of all, at how replication works within a site, or in other words, intra-site replication, as you see up here in my little title. Now, the reason why I want to show you this is because this is really going to be relative to understanding why we have to have multiple sites sometimes. But here, let's just say I had a single building. It's kind of a big building of, lots of employees if I got 6 domain controllers here. But a single location, all of my domain controllers are maybe even in the same server room and everything like that. Single site. Now, what would happen here? Well, in this intra-site replication, here I would have maybe a user account that gets created on this domain controller. So I got my handy little user account that I just created, maybe a new employee or a new victim, if we want to call them that, something like this. And once I create that user account, what happens and how do we eventually get that same information in Active Directory to replicate all the way through to this most distant domain controller so that we have the same information on all our domain controllers? And when that happens, that's known as convergence. Well, what happens here is, as soon as I create that account, it'll wait 15 seconds, okay? And then it'll replicate to its next replication partner in the ring. It normally starts off with a ring topology like this, a bidirectional ring topology. So then it'll wait 15 seconds to send that information here. But it'll also wait 15 seconds plus 3 seconds to replicate this direction. And the reason why it does that is to stagger the network traffic a little bit. So it'll kind of go both directions here until it eventually will wrap its way around down to this domain controller down here, where we'll eventually have that same user account created in its copy of Active Directory, or replicated to it. So what happens here is you're limited to 3 hops, and that's because the knowledge consistency checker, or the KCC, limits itself to 3 hops, and that way it can provide convergence in a timely fashion. Used to be in other versions of Windows, like Windows 2000, that this would take 15 minutes between hops, and so you could be, 15, 30, 45 minutes or so between full convergence within your single site. Well, Microsoft realized that that's quite a lot of latency for a single site of high-speed connectivity within all these domain controllers, so that's why they backed it down to 15 seconds. So now we're looking at, 45 seconds, maybe if you got the +3 over here, you're looking at under a minute at least, and that's pretty good. However, you might have more than those domain controllers. What if you have more than just 6 domain controllers in your organization? Well, in this case, for example, we have 8 domain controllers. So here we have a user account that we're creating. And here's the most distant domain controller down here. So what the knowledge consistency checker will do in this case is it will create connection objects between all your domain controllers, and it will figure out what is the shortest way to get to the most distant domain controller. And in this case, it'll have to create what we call optimizing links here in the middle. And these are things that go outside of our normal ring topology to kind of shortcut us to the most distant domain controller. So we still have 3 hops in this case because, again, remember the KCC limits us to 3 hops. So we have 1, and that would be our first hop to get to this, domain controller right here. And then we have a second hop over here on this optimizing connection to this domain controller over here. So now we have the user account there. And then finally we have our third hop down to the most distant domain controller. So eventually we wind up with that user down there as well, although strangely they shrunk to about half the size. Don't ask me to explain that. So anyway, we eventually get that user all the way down to the other location, again because the KCC creates these optimizing links in the middle. That's intra-site replication. For the purposes of our current exam, you will have to know that just kind of as a foundational knowledge. I don't think you'll have a specific exam question on that, but that will help you to understand other things about replication when it comes to configuring your sites properly. So here's where sites are really going to start to take place and play a factor in our replication. Because you see, by default, everything goes into this default first site name. And if you go back to Server Manager and Roles and Active Directory Domain Services, you'll see that under Active Directory Sites and Services that we have this default first site name. And I've got a few other servers that I've installed here. Notice that they all appear here in the default first site name. Okay. Now, that can be a good thing if they're all in the same site physically, the same building or whatever. But if they're actually geographically distant and connected by WAN links, that's not so good. So for example, here I've got a Phoenix domain controller. I've got two Phoenix domain controllers in Phoenix. Maybe they're all in the same building. Okay. Here I've got Tucson domain controller and another Tucson domain controller. Again, same building, maybe same rack even, So the thing is, when I install all of these, it lumps them all into the default first site name, like I showed you just a moment ago in Server Manager. Therefore, these domain controllers, all four of them, think that they are in the same physical location as well. And now when I add a user account up here, then it will do the 15-second thing to replicate that account over here to this domain controller, and then 15 seconds to this one, and then 15 seconds back to this one if it hasn't already replicated this direction. So the convergence takes place on an intra-site replication schedule. This might not be so good because, let me clear it up a little bit here, because there might be a slow WAN link between the Phoenix and Tucson offices. What if that's a 128K WAN link that we're already passing other traffic on, and it's already 75% saturated and utilized, and we have very little bandwidth to spare, and yet we got this, really sporadic traffic that goes back and forth because it thinks it's in a single site. That's where it comes in handy to divide the thing into two different sites. And here I might have the Phoenix site. I'll put Phoenix like that. Here I might have the Tucson site. Okay, so I have two different sites. Now what would happen is, instead of having them all in the default first site name, they have their own separate sites. Between them, they will still observe the intra-site replication scheduling. And over here as well. However, between the two of them, we'll have a bridgehead server, which we'll also talk about more a little bit later on, but that's the single entry and exit point for all replication between the two sites. Now what will happen is, this will happen by default every 3 hours. It'll store and forward. It'll store up any changes that have been taking place in this domain, or on this domain controller in this site, and then it will only send them every 3 hours by default over to this other domain controller, and that's a lot smarter use of our network bandwidth. And what's more, once I divide these up into two separate sites, I can also schedule that so that it would only happen during certain times of the day or night. Let's also talk a little bit more here about what sites are. A site is normally going to mirror your physical topology. And that's why in the previous diagram there, I showed you Phoenix as its own site and Tucson as its own site. Why? Because it mirrored the physical topology. I had two local connections of high-speed connectivity, so that was a representation of my physical topology, and they were divided by a WAN link. That divider, kind of logically caused me to separate the two into two separate sites. It's also generally going to be an area of user community, so you'll probably have a clump of users all there in Phoenix, another clump of users all there in Tucson, and it's generally going to be reliable, high-speed network connectivity. And because of that, that's why it's optimized for intra-site replication, where it waits only 15 seconds to do the replication. Although Microsoft considers 512 kilobits per second fast, you're probably going to have 10, 100, or gigabit E networks there that connect your LAN connections. And generally, again, a site is also going to represent your mirror your physical topology, and each site probably being its own LAN. Okay. Also, the sites are going to be domain independent. Let's go ahead and take a look at a previous diagram I think I've used in the past. And let's look at, for example, newyork.east.nuggetlab.com. This could be a site. I might have a site for all of my New York users. It's a local area of high-speed connectivity. It's got a user community in there. Maybe I got a few thousand users, and I got several domain controllers for newyork.east.nuggetlab.com. It could be, however, that I have people from Texas that regularly visit this office in the New York site. So this will be the New York site. Okay. Now, since they regularly visit this site, maybe we want to go ahead and put a domain controller from this domain over here. So we'll just plop in a domain controller from Texas, and it's also going to be in the site. And now we've also got texas.south.accusource.local located in the New York site. So don't think that there's always a direct correlation between the name of the domain or the geography of the domain and the site itself. And to take that further, maybe I've got a Phoenix office, which is also our headquarters. So we've got nuggetlab.com in the Phoenix site. We also have west.nuggetlab.com in the Phoenix site. And, of course, arizona.west.nuggetlab.com all in the Phoenix site. So I might have 3 domains all in the Phoenix site. Okay, so that's just something to think about. Once again, it's domain independent. Your sites are not necessarily locked into a specific domain. And once again, here also, maybe I have users from Texas that regularly go to my Arizona office. So once again, I might plop into my, running out of room here, I might plop into this particular site a domain controller from Texas. So now, in addition to these 3 domains in the Phoenix site, I also have texas.south.accusource.local. So you see how that can kind of get scrambled, and you have to be careful not to lock in your thinking into strictly the names of your domains. Also, another thing that sites will do for me is they will help me to localize the access. So, for example, let me just take a look at another diagram here. I think I've got one here that I can use. We'll talk about this one a little bit more later on for some other purposes, but here I've got my Phoenix site, and I got a couple of domain controllers there. I've got my Tucson site, a couple of domain controllers there. When I have a user up here that tries to log on to their workstation and log on to the domain, I don't want them to query a domain controller down here in Tucson to process the logon request. And then we're assuming that these are all in the same domain, by the way, for the time being. So instead what I wanted to do is I wanted to query its own local domain controllers and to avoid this WAN traffic by having to be authenticated by a distant domain controller. By configuring sites, this will help us to make sure that when we log on to a domain controller, that it first looks for a domain controller either in its own subnet or in its same site. Other things that this can help to localize are things such as your Exchange servers, which are going to be site aware, and they will be able to service clients locally in their same site, or the distributed file system, or DFS, that again will be site aware and will service clients in its own local site as well. And of course, by keeping all that data or all that access localized, that's going to help us to control the WAN traffic, as well as being able to schedule the WAN traffic so that only the replication only occurs possibly during off-peak hours. Especially for those sites that are connected by slow or unreliable WAN links. If you have really high-speed connectivity, you might not need to schedule it for off hours, but at least it still helps you to smartly manage your WAN traffic. Now, at this level, you should probably already know how to create sites and to move servers between sites and the like, but just for sake of context and as a quick review, I'm going to quickly do that right here. First thing I want to do is I want to rename the default first site name. Now, let's just assume that we have Phoenix and Tucson here. So I'm going to right-click, choose Rename, and I'll just call this one my Phoenix site. Okay? And then I also have another site that I want to create, and we'll go ahead and right-click here, choose New Site, and I'm going to make this one my Tucson. Okay, we're going to associate that with our default IP site link, which also needs to be renamed, by the way. This just simply tells me that I need to also put the appropriate domain controllers in the Tucson site, because as you can see, there's nothing there right now. So maybe we have server 3 and server 4 that are actually in the Tucson location. So I could take those two and click and drag them down here to the servers. This simply tells me that group policy object may change based upon the fact that I've moved those two servers. And now I've got two servers servers located down here. Also, remember that if you do need to perform any kind of replication, that you can do that by right-clicking on one of these connection objects, which are automatically generated by the knowledge consistency checker. And then for connection objects between two sites, there's a subset of the knowledge consistency checker called the Intersite Topology Generator, or the ISTG, which also automatically generates some of these things. So I'll just go ahead and replicate now, and it's replicated the connection. So it's a pretty easy way of being able to do that. Another thing you can do, if you want to trigger some replication from a command line, if you run this as an administrator, then we can also do rep admin, and then you could do a sync all. And this is likely to fail, by the way, right now, because I just created the sites, the site differences, and that has not yet replicated to all my domain controllers. Oh, actually, it did work. So it's sync all terminated with no errors for the time being, so that looks okay. So anyway, now we've got them in different sites, but we're not quite done yet either, because this to be site aware, for my Active Directory to be site aware, and for my applications to be site aware, and so forth, then I need to also associate different subnets with each one of these sites. Okay, so I'm going to go up here to subnets, and I also need to go to my IP and rename this default IP site link. Remember, I mentioned that earlier. So I'm just going to rename that. I don't have to. I can leave it the way it is. But it'll make more sense and be more intuitive if I name it something that makes sense, like Phoenix Tucson, and Tucson spelled T-U-C-S-O-N. That's why we just spell it T-U-C there. By the way, another thing you might want to put in here is the speed of the connection. So maybe it's a T1 connection. So I'll put 1.54 megabits per second. Okay, megabits per second. Okay, something like that. That will help me to get at a glance. I can easily tell how fast the link is. It doesn't tell me about how saturated it is or how much is available, but at least I get some rough idea of its performance there. All right, now let's go ahead and make our subnet items right here. So I'll right-click here, choose a new subnet, and maybe my Phoenix subnet is on 10.10.10. And we use the address, the network prefix notation here. So it'll be 10.10.10.0, and let's say a 24-bit subnet mask, which would be like a Class C. So that's what my Phoenix site is located in. Okay. Now I might have more than one subnet in Phoenix, so I might do another one here, and I'll just right-click here again, new subnet once again, and I'll call this one 10.10.10. Or actually 9.0. 24-bit subnet mask again. Maybe I've got that subnet also in Phoenix. Maybe different floors or different closely associated buildings or something like that there in Phoenix. Then the other thing I could do is to create my subnets for Tucson. Maybe I only have one subnet in Tucson. Okay, so maybe in Tucson, oops, I guess I better not spell it, I gotta type it in. Okay, so let's make it a 10.10.8.0, 24, and that's my Tucson subnet. Okay, and so you can see here now that I've got these different subnets all associated as you see. If you ever need to make any changes, like maybe I put this in the wrong site or something like that, I can right-click here and go to Properties and change it back to whatever other site I was interested in. I'm okay with it the way it is for now. And of course, the advantage here now is that when one of my clients in Tucson, when they log on, when their computer starts up, they probably get an IP address from a DHCP server, and that range, the IP address range that they get, is going to be in the 10.10.8. whatever family. And so when it gets that IP address and it looks for its domain controller, it's only going to receive domain controllers initially, at least, that are also in its same subnet. So one of these domain controllers down here. Now let's take a look at this diagram to kind of illustrate what we just did. We created two separate sites for Phoenix and for Tucson. And we created a site link in between them, which is the logical representation that passes back and forth the replication. We also, and this is not something we manually do, you can do it manually, but this is something that the knowledge consistency checker through the ISTG does for us, and that is that it creates a bridgehead server. A bridgehead server is a single domain controller selected by the ISTG in each site to be designated as the entry and exit point for all replication. That way it avoids me having replication take place, kind of in a shotgun approach to all domain controllers all at once from this site up here, because that will help us to conserve our network traffic if we focus on one. And then 15 seconds later, of course, once it receives the information, it replicates it to its partner. Now, the way the ISTG, by the way, selects bridgehead servers, all other things considered equal, is that it will determine whichever one has the highest unique identifier, or globally unique identifier, or the GUID. So it's kind of a haphazard way of selecting it, but normally it's not too big of a deal one way or the other. You can manually select your own bridgehead server if you want. I don't recommend that unless you get to a highly complex network environment where the ISTG's selections don't seem to be working for you. So if you needed to select your own bridgehead servers, here's what you would do. And you can do that by right-clicking on a server, choosing its properties, and then choosing IP and add. And now this is going to be the bridgehead server. We'll discuss SMTP in a future time here in this same nugget. But anyway, now I've manually selected this as my bridgehead server. This does have some implications that you should be aware of, however. You see, if I manually chose this bridgehead server right here, and then it fails, maybe it caught on fire or whatever, then there's no way for the ISTG to automatically select this as the backup bridgehead server or to replace it in any way. I would have to then manually remember that that was the bridgehead server and then manually go in here and make this one the bridgehead server. Likewise, because I've chosen this as the bridgehead server now, there's no way for this bridgehead server to know that I've made that change because it never received the replication. Why? Because this bridgehead server's dead. So now I would have to also go down here and also select that this was the bridgehead server in the interface on this domain controller. So that's a lot of manual work that has to take place. Otherwise, if you allow the ISTG to select the bridgehead server and this one were to go down, then it would automatically reassign the bridgehead server to another domain controller in that same site. So again, better to let the ISTG select the bridgehead servers for you, unless you're in a very complicated environment where you just have to do it. Let me show you something else here, by the way. I'll go to run this as administrator. If you want to know which bridgehead server is the bridgehead server, then you could just run, let's see, what is it, rep admin. I don't think you need to know this for the exam. I'm just telling you for, posterity's sake. Then you would type in /bridgeheads. I think that's what it is. Yeah, that is it. And then it will tell you what your bridgehead servers are for each individual location. So the bridgeheads for the Phoenix site are going to be DC Nugget 1. Now I know what my bridgehead server is. The bridgehead for this Tucson site is DC Nugget 4. So now I know what the bridgehead server is for Tucson. If you want to get really verbose, you can do a /v here, and it gives you information like when the last time was that replication took place, when it was last successful, what time it was, all kinds of other information there. But that's, again, probably not an exam issue, but just very useful, especially if you do run into troubleshooting issues later on. And if I haven't already mentioned it, by the way, as well, your bridgehead servers, you should usually make those global catalog servers. And the reason for that is it's going to keep us more up to date with our global catalog data. Now let's take a look here at something called the hub and spoke topology. This is something that Microsoft kind of recommends as a starting point, at least. It can get more complicated than this, of course, especially if you have a whole bunch of different sites. But here I'm keeping the diagram simple so we can fit more on the slide here, and that's readable. And what we have here is maybe a headquarters office or something like that. Maybe this is where most of the action takes place in the company. This might be my hub right here. Okay, and then I have two branch offices. These would be my spokes, okay, or at the end of a spoke, I guess you could say. And we can have bidirectional replication traffic happening there. And then if I might have other domain or other sites as well, maybe in some other office over here, some other office over here. So you can see the hub and spoke pretty well describes how this might look. You're generally going to use this kind of a thing when you have really high-speed connections here, and then you're going to have slower connections to your remote offices, your branch offices. And so that's a logical representation of what we'll very often have. And this is probably your most common kind of an interface, kind of a thing that you'll see. You could also have, a full mesh, and that gets really messy, where you'd have not only, this site right here. Let me clean up a little bit. This site right here is connected to this one. This site here is connected to this one. And you have these two that are also connected through some other kind of a WAN link. Now, you can't have that, but if you do add additional hubs and additional branch offices, some organizations have hundreds, if not thousands, of branch offices. And if you put all of that in a mesh topology where every site is also connected to every other site out there, then it grows exponentially and it becomes almost unmanageable. So certainly a hub and spoke is going to be simpler in that case. However, if you do need to expand this out to a little bit more elaborate kind of a replication, you might instead go to a hybrid replication. In this one, maybe we've got our three sites that we already talked about over here, but maybe we have our other office over here in New York, and it also is in a hub and spoke replication over here. So here's hub and spoke, and here's hub and spoke, and we've also set one additional site link between these two hub offices. And this helps to eliminate a single point of failure in terms of our redundancy. You know, we're still going to have some outages, but if this whole hub, this whole network hub for some reason had a network outage, at least we would be able to still have this hub right here communicating with its other sites down here, and at least we don't have a complete network outage across the entire company. One of the other things you want to take a look at here is site link cost. Now here I only have a single site link, so there's not an awful lot to configure because site link cost is only an issue if there's more than one site link. But here, if I take a look at the properties of it, you'll see that by default it has a cost of 100, which is kind of an arbitrary number that Microsoft put in there. You can put whatever number you want in there, and the way you decide which number to use is you just have to establish a system of your own. And I'll show you what I normally do here in just a moment, but like I said again, 100 is the default. And it'll also replicate every 180 minutes. You can make that as small as every 15 minutes, which is very often what I actually prefer. As long as I've got reasonably good network connectivity, I'll usually back it down to 15 minutes because a lot of times, unless you're in a special case of some kind, your Active Directory replication traffic probably won't take up much more space than, you know, an average email or something like that. So I'll usually back that down pretty well. Now the other thing we can take a look at here is I'm going to use a diagram here to identify how to configure the cost. Now here I've got some WAN connections that are going on between a couple of different locations. Here I've got my Phoenix site, and here I've got my Tucson site for the same domain. Just to make it simple, I've got Nugget Lab in both. Here I've got a T1 line, which is normally going to be a 1.54 megabit per second. Okay, and then here I've got a 512 kilobit per second link between Tucson and a little town called Chinle, which is in northeast Arizona, which is kind of an interesting little town because they're known really for their proximity to a place called Canyon de Chelly, and it's a little bit more of an outlying area, so I'm going to say that it has a slower WAN link right here. So, given these numbers, that I have a 1.54 megabit per second and a 512 kilobit per second between these two locations, then I'm going to make this one, the cost of this one, 3 times the amount of this one. Let's go ahead and see how that might work out. Here, if I go take a look at it in my cost, if I had a site link for my connection between Phoenix and Tucson, if I set that up as a figure of a cost of 5, then here I've got a site link between Tucson and Chinle. Well, Chinle has a bandwidth of 512 kilobits per second. Therefore, it's 3 times slower than my 1.54 megabits per second up here. So I'll take 5 and I'll multiply that by 3, and that gives me a cost of 15, because again, it's 3 times slower than this connection. And so it's important to carefully observe what your WAN link connection speeds are, and if you upgrade one of them, for example, you want to make sure that you also change the cost so that you have the inter-site topology generator can make intelligent decisions as it calculates the best route from one location to the next. Now then, let's return to this dialog box where I want to go look at this change schedule item. Maybe every night between 10 and 12 p.m. I have some kind of a backup program that runs, and it chews up most of the available network bandwidth. Well, I don't want to have to compete with Active Directory replication traffic during that time, so I can schedule this to not make replication available during that time, and that way it doesn't have to compete with some other kind of network traffic. Other purposes for this might be, maybe you don't want it to replicate during business hours. Maybe you can afford to wait a while for convergence. Maybe it's a highly independent office on the other end of this WAN link, and they don't really probably need to have extremely up-to-date information. So, you know, every morning between, let's say, 7 and 6 p.m., we don't really want to make a replication available during those times. Actually, I guess that's 5 p.m. We don't make replication available during those times so that users can use up the network bandwidth for other purposes. So just an idea there, you can exclude or allow replication traffic according to what your WAN traffic is like. Now let's also take a look at what site link bridging is. By default, there's a setting in the IP transport that says bridge all site links. What this means is, by default, this Phoenix DC01, we'll call this a bridgehead server, and this a bridgehead server, and this a bridgehead server. What it can do is it can, of course, replicate to Tucson DC01 because we have a connection object here, which is associated with an actual physical WAN link. So this server here replicates with this one. Nothing unusual there. That's doing what it's supposed to do. Then we also have, and again, if this is the bridgehead server, it's able to replicate to Chenli01 here because it has a connection object that's already established as well, and that, of course, that reflects a WAN link connection between these two sites. Now, what if Phoenix DC01 wanted to replicate directly with Chenli01? Well, what happens here is it can use the physical WAN link and the associated connection and this physical WAN link and associated connection to directly go and immediately replicate back and forth with the Chenli connection. And because the option for bridge all site links is turned on, it's able to do that. Now, if we were to deselect that, or if somebody were to just accidentally deselect that item, then what we would have to do is this domain controller here would replicate to this one, and then we would have to wait for our normal replication schedule for this one to replicate with this one. Okay, so that's where any information from Phoenix DC01 would actually come from Tucson DC01 in the normal replication schedule. So if this was 3 hours, and this was 3 hours, then we'd have at least a total of about 6 hours before Phoenix DC01 data would get replicated down here to Chenli01. But because bridge all site links is turned on, these two domain controllers can directly replicate with one another. Now, this would work kind of out of the box the way it is, but if you have a more complex network scenario where you do not have a fully routed network, and by the way, that's what this is. This means that there's no WAN connection here, so that we don't have a fully routed network. Then we might have to get into situations where you have to custom configure your site links. Let me go ahead and show you that. Here, if I go to the IP properties for my inter-site transports, you'll see that that's the option I mentioned earlier, bridge all site links. That's what allows us to have Phoenix DC01 to replicate directly to the domain controller down in Chenli. Now, what I could do here, though, is, especially if we had to custom configure a lot of this stuff ourselves, is if I needed to, I could deselect this item, and then I would create a new site link bridge, and I would say I want these two site links to be in the bridge, and I would just call this one, Phoenix-Chenli, okay, site link bridge. And then I would select those two items, and if there was, more, you could pick and choose as you need, and then click OK. And now you can see that I have a Phoenix to Chenli site link bridge. Now, in this case, this is probably not something I would necessarily have to do here, but if I needed to create a site link bridge, certainly that's how I would do it, again, especially in a non-fully routed network. And what that's going to help do is to make sure that I get timeliness between an originating domain controller and the final destination domain controller. And if we were even more complicated, maybe if there was another site here and another site here, you can imagine that if we have site links here and site links here, and then finally site links here, that this could take 3, 6, 9, 12 hours to eventually get down here. Then we want to create that site link bridge instead to hurry things along. And what happens then is Active Directory kind of logically sees, it kind of pretends as if there's actually a WAN link here, at least in terms of its replication cycle, because it's able to go immediately through this whole loop. Also take into account some special considerations, and by the way, for exam objective purposes, I would be very well aware of what I'm about to tell you here. First of all, you have a firewall, of course, that's going to separate your site from the WAN links and from other sites. Okay, so there's going to be firewall entry points, and you need to make sure that it will be able to pass RPC traffic, or remote procedure call traffic. There's a really well-known speaker that speaks at a lot of the Microsoft conferences named Steve Riley, and I've spoken at some of the same conferences he has, and he's written a really good article that's located at this tiny URL address point. So just jot this down. If you want to pause for a moment, you can, and that will take you to this particular Microsoft TechNet article, and again, you can see written by Steve Riley, where he tells you all of the different things you need to do in order to make replication work and how RPC works and so forth. And it's really more information than we need for our current exam purposes, other than to know that you do have to open up the firewalls for RPC. Now, another thing you might want to consider, and this would be like a special scenario. Maybe I've got a site right here with DC1, a domain controller 1 there, and then DC2, and then I have an LDAP server here, an LDAP application. Okay, and let's say that this is an extremely chatty LDAP application, and it's constantly hammering these domain controllers with LDAP queries. Well, we don't really like that. These are too busy servicing my actual users and other computers and everything, and I really don't want them hammered with this LDAP application. So what I can do is this. I can set up a dedicated site and move that LDAP application down into its into the same site, LDAP application. Okay, and this is not really in the same site; it's going to be in the same subnet. Okay, so put that LDAP application in the same subnet as another domain controller. I may have to install a third one here that's dedicated only to servicing this LDAP application. And since both the domain controller, which is in this site, and the LDAP application, which is in the same subnet, then this LDAP app, every time it's looking for a domain controller, it's going to find this one, and it's going to perform all its queries against this domain controller. These two then will be in whatever site they're already in and be able to service my normal Active Directory clients just fine. So I can use this dedicated site for my LDAP apps. I put a domain controller in there along with the application server that's performing all the LDAP queries, and it could be a good solution to make sure that I can isolate those LDAP queries to a specific server. Another consideration to think about here would be where I might want to minimize my replication. Maybe I've got a forest here. Okay, let's just put in, an empty root up at the top. Maybe that's for my university. Okay, and then here I've got a medical school domain, and here I've got a business school domain. Okay, so in this case, all the domain controllers throughout this whole forest are going to eventually be replicating possibly a lot of data, especially in a very active environment like a university, where students come and go, and they're in the tens of thousands. It's not like just a normal corporation where, every now and then someone quits or gets fired, but it's not like we have thousands of things going on every day. And we have users, here in both these two schools changing passwords and so forth. So anyway, there's a lot of replication traffic that takes place, for example, with a global catalog. So if I have global catalogs in each one of these domains, remember that they all contain every object in the entire forest. As a result, the replication burden is possibly going to be larger, especially since this is a very active organization. So, large organization like a university with a lot going on here with this replication, I might decide to just split that into two forests or design it as two forests in the first place if I've got the foresight for that. So here I would just have my medical school, and then here I would have my business school. Okay, and then they would each be their own forest, and then if I needed to, of course, I could set up a forest trust so we could still exchange resources, but they're their own forest, so therefore the global catalog servers in each one of these domains is not going to have to share the burden of an entire other domain over here. Okay, so we just set up the forest trust, and then it avoids replicating everything throughout the global catalog servers. And in this case, the global catalog servers will only contain all the objects in each respective forest. So this is a forest here. Global catalog server contains only its objects. This is a forest here. This global catalog server contains only its objects, not both of these forests. In this nugget, we took a look at Active Directory physical topology. It's important to understand that physical topology because without it, you cannot properly configure sites. One of the first things we looked at, though, was intra-site replication, which we saw was horrible for WAN links. So because of that, you need to set up separate sites of high-speed connectivity and then connect them, of course, with your physical WAN links. That's the physical topology part of this. Once you've got that configured, though, you need to properly configure those site links. And site links can be used using IP, which is what we used, but you may have also seen that there was SMTP there. We'll be taking a look at that in our next nugget. I didn't want to cram too much in this particular one, so we'll save that for the next time. Then we'll also have inter-site replication once we've properly configured our sites and our site links. And the replication takes place through bridgehead servers in each site, which are automatically configured, but you can manually configure those as well. And then we took a look here at the site link bridge, which is great for making sure you have transitive replication in non-fully routed networks. And then finally, we took a look at some very important considerations in terms of the exam objectives. So pay special attention to that part as well. Well, I hope this has been informative for you, and I'd like to thank you for viewing.